Hi there. So in this video I work on a DSL201 combo chassis that's been turned into a head. It's that one on the top. So it has an issue where you're playing away on it and intermittently the volume will fizzle out to nothing, turning it off and on again, and you'll have volume for a bit potentially. I have diagnosed the problem. It's so intermittent I haven't been able to make it happen on camera, but I have diagnosed the problem and tapped around inside the amp with a non-conductive object and found that C93, capacitor 93, which is one of those polyester capacitors like that. They're often referred to as box capacitors. A value written on the top. Are they polarized? I don't think they're polarized, but I always make sure that when I reinstall them I put them with the writing in the same orientation as the cap that I took out. To be honest, I don't really think it matters. There's also a problem on that amp that's been there for ages and ages and ages, but I've never really bothered about because I only ever use the red channel on it, and that is that the channel switching on the front panel hasn't worked for a long time. It works on the rear panel, so I have a little go at fixing that, and I try a random component substitution that doesn't really work. It doesn't blow anything up, but it causes the circuit to not function as intended. So that's interesting, and it sort of shows that if you've got a transistor like one of these, stick to the rated type. Don't try and substitute different things unless you've got no choice, of course. But in my case, it was just what I happened to have around, and I thought I'd give it a go, but it didn't work out. As I say, no harm done. But the other thing that I tried, where is it? Was this filter capacitor. It's perfectly functional. It's a Sanwa, Chinese. See, I would never buy these if I was shopping for capacitors, just because for the price of a capacitor you just as well buy the best you can find. So I replaced this capacitor, a perfectly healthy capacitor, with one from United Chemicon, who I believe are Japanese. But anyway, they're a recognised brand, and they make decent capacitors. Now, I have always bought the best capacitors I possibly could, just because quality, durability, longevity, consistency, all that kind of stuff. But I had thought, well, capacitating, right? If you've got a cheap capacitor, but it's meeting the same specifications, if it's providing the same level of capacitance, then it must be okay, right? What difference could it make? It'd be like saying, oh, those electrons sound better than those electrons, which would be a nonsense, right? But I got surprising results when I swapped this for a better one. So watch the video, stick around and see that. Sort of maybe, I don't know, perhaps not as surprised in retrospect as I was at the time. I mean, I don't know if you can see that, but in the middle of my stack, see that little device flickering away there? That's a power conditioner. What that does for me is it conditions my power. It gives me better electrons. So it enables me to have a consistent output voltage into my amp. I actually found, this is a couple of years ago, that those fluctuations you can see there were sometimes not so much audible, but discernible. There would be like a variation in the tone, and I really couldn't figure it out, and I thought, sorry, itchy eye. I thought there was something wrong with my amplifier, and I was like chasing ghosts, and I don't know, something made me Google power and the tolerances that are permissible, and I can't quite remember the specifics of it, but it's something like plus 10% is permissible or something. I can't quite remember the specifics, but it's quite a wide variance of voltages is permissible. And I thought, oh, that sounds a bit weird, surely. With the whole thing with variacs and all that type of stuff affecting your tone. And also another thing, I wasn't gigging at the time, but I was practicing a lot with a band. We were just working up to gigging, but we never bloody got there. But one thing I noticed when we were going from place to place, is obviously different rooms sound different, but I was sure that playing in different locations, not just the like kind of room ambience, like the natural reverb and reflections and all that sort of stuff was different. I was sure my amp was sounding different, and so ultimately, with all this kicking around in my head, I bought one of those things, and then lo and behold, going to all these different places, the flipping voltage was different, wasn't it? Voltage was lower in one place, voltage was higher in another place, and yeah, power conditioner kind of at least in this location in my house, I always get the same sound now. Cool. And another advantage is if there are surges and spikes and all that sort of stuff, then my kit won't blow up. So that's got to be good, isn't it? Yeah, that's the little side on that. So yeah, changed caps, and yeah, difference happened. So a lot more soldering will be coming up, I think. And I really must, just for the sake of honour, fix that channel switching problem. But yeah, on with the show. So, as is always the way with these things, fault won't... Shh, I'm trying to talk. Fault won't present itself on camera. Previously, what I was able to achieve is, when the amp fizzles away to nothing, I was banging around with a non-metallic object on C93 capacitor near the bridge rectifier, and making the amp cut out. You may notice a lot of the wiring in this amp is labelled up with numbers that identifies the connector numbers corresponding to the wiring diagram. Now, I didn't just do that now with the amp as it is. This is actually my own #1 amp, and I did all of that ages ago, and it's just persisted. I've made loads of customizations and mods on this amp. It's actually made from a 20-watt combo. But anyway, enough waffle about that. Let's turn this thing off, get it unplugged, and I'll show you how I discharge the capacitors. The capacitors, you can see, are the bigger ones are these cylindrical objects, and the legs for those capacitors are all on the other side of the board, so you can't discharge them from the top, you have to discharge them through the circuitry. So what I do is I get my capacitor discharging rig that I made, or assembled, put together, or whatever, and discharge from the supply wires into the board, and just about anything else bare that I can find I touch against and leave it there for a minute or two just to discharge everything, and then I test across these supply wires and the standby switch and the circuit and earth, and just make sure there's not any voltage kicking around. So I'll show you that. Okay, so the amp is off, it's isolated from the power. There's the power there, all unplugged. Still got speaker load connected, that's fine, it's not going to do any harm. It might help to dissipate some energy in the amp. So what I should do first is open up the power and the standby switches. Turn those two on. Open up the circuits. So we've got the amp isolated from the power, there it is disconnected. So what I'll do now is open up switches, power on standby, so the circuit's all closed, and if there were power it would be flowing. So my capacitor discharge setup consists of these alligator leads, or alligator clip leads, these, oh get the amp. They're just a simple set, and a high power resistor. You can't tell from looking at this, but it's well, it's 10k, you can tell that much, and J is a tolerance. But this model, HS25, is a I believe 25 watt power resistor, which is perfectly adequate. 10k is the resistance value, so I use this on any size of amplifier for discharging. And I don't believe it's polarized. So just pop that down there, and then connect one side to a ground, so somewhere on the amp chassis. Hopefully you can see that, yeah. And then connect this side to stuff you want to discharge. And just hold it there. For like 10-20 seconds. Be sure not to short circuit anything. So far, things that I've picked are the standby switch. I'll do both wires on that. Although it shouldn't really matter because the switch is closed, so both sides of the switch will have any voltage that's lacking in there. And also shorted on that fuse, not shorted, connected across that fuse, and this nice resistor that's standing up there. See if there's anything else really that you can pick up on. There's a nice big resistor there. Any supply wires to the valves. Okay, so when you think you've stuck your capacitor discharging rig across every damn thing you can find that offers you opportunity, so any supply wires or whatever you can find, get your multimeter, set it to volts, DC volts if you've got it. This one's auto ranging, and have a probe. Touch a nice bare part of the chassis, and then probe all those bare things, looking for voltage. Little readings in the millivolt range are okay. You'll get those anyway if the circuit's not made. So you see, touch the two leads together and we get close to zero. So keep an eye on that. If you see anything in the volts range, do more discharging. Poke and probe all the things. Okay, I think we're all good. I'll show you what things look like on a different multimeter. Okay, so this one's a bit more traditional. This one's not auto-ranging. So I've set it to the millivolts range, and I've set it to DC, volts DC. And I'm going to hook my probe onto something good. What about my lead? My alligator clip. There we go. We're connected. Gives us a little check. Yeah, we're all right. So again, we've got that thing where we're picking up like a few odd millivolts from just being in the air, and we'll probe around. So as this is the modern age, I took some photographs on my phone of where the wires go, which would obviously be much more efficient than labelling all the wires, like we used to have to do in the old days, before technology. Okay, moving on. Right, here we go then. So, guitar disconnected, speaker disconnected, get all the knobs off. Okay, so there's the back side of the board. You can see it's seen a lot of action. And the object of interest to us is C93, which is near the bridge rectifier. That chap there. So there are the legs for it, these two. Can't see a dry join or anything, but I'm going to replace C93, which is these. I guess I can point here. These two joins, C93. So I'm going to replace C93. This chap here, C99, I've replaced that a few times, changing the value. What have I got in there at the moment? 2 nanofarads. I think like 0.22 was standard, and I progressively upped it until I got a level of bass that I liked. So I found this amp lacked bass with the standard capacitor setup. So set you up again in a different position, and we'll get C93 desoldered and removed, and then we'll replace it. Hopefully that will solve our issue. So another thing that's wrong with that amp, and has been wrong for a long time, is channel switching. So channel switching from this switch, which lives on the front panel, hasn't been working for some time, but channel switching from the foot switch has been fine. I suspect this transistor, I just looked up the numbers on this transistor to see what it is. It's a 40 volt NPN transistor. I had to use magnifying glass that I can't see now in order to read the numbers of this transistor, and I've raided my stash for parts, and I have found a bunch of transistors. This is actually a different code, but it's also an NPN transistor. This one's rated for 60 volts, so should do the job. Or will it? I'm not sure if I can make this substitution. I'll Google, find out if I can. Because voltage might be what activates a transistor. I'll be back. Okay, well I'm back from my little bit of Googling. I don't know, to be honest. So I think what I'm going to do is I'm going to test this transistor in this little gadget, and if it fails, then I'll replace it with a 60 volt one and see what happens. Okay, so I'm going to start and get all my soldering kit. Okay, so we're going to take this transistor out of circuit and test it. Need a solder braid. So another thing I'm going to do while I'm here is shoot the switch absolutely full of this stuff, electrical contact cleaner. I think I'm just going to try this with the uncertain 60 volt transistor in it, and I'll order a replacement for this one, rated at 40 volts, the same. I'm sort of thinking there's no problem with this board and the problem lies somewhere else, but I don't know. But here's another part that I bought that I've been meaning to fit for ages. So this larger capacitor here, this is the main filter cap. It is a Samwa. I mean, it works, but it's like a cheap Chinese capacitor. So I'm going to replace it with this one. So this is a United Chemicon capacitor. It's a much better brand. Will it sound any different? Probably not. But it's nicer. Okay. Now on this side, the cap is hot glued down. So chip away at that hot glue. Oh shit, careful Graham. Okay, that was some seriously tenacious hot glue, but we managed to do it. We got the capacitor out. We observe the polarity of the cap. The minus negative side of the capacitor is marked. Positive side of the capacitor is marked on the board. So okay, we need to kink the legs. This is flux. I've got a soldered flux dispensing pen because it's so convenient. Gonna use my super duper eyes. Check my joints. They are beautiful. So that's that one. So now we've got to relocate C93. There he is. Pop that little chap out there. There. Okay. So find a component on that side. It's there. So same drill. Solder sucker. Okay. To make life easier for myself, I'm going to cut the legs of this component right down. That's fine. You can fall if you want. Okay. So the same thing. Now I'll grab the component from the component side of the board. Remember it's C93, this one. C93. Grab him and pull. He's coming through anyway. Come on, out you come. There we go. Now we get our replacement. So here's my little gadget again. So here's the new capacitor. Pop it in there. Give it a little test. It says it's a capacitor, 21.27 nanofarads. Here's the old part. Pop them in the tester. Leads are just long enough. And it says it's a capacitor, 20.79 nanofarads. So as I suspected, the capacitor itself isn't testing bad. The whole problem's horribly intermittent. Really not sure if we've actually nailed it. We shall see. And I'm just actually before I stick that capacitor in there, just going to make sure I've cleaned the holes through the board out properly. And again, the way in which you do that, the way you do gravity-defying solder removal, is you use a solder braid. Wind out a fresh part. There we go. Okay. Seems like the holes were clear anyway. But better safe than sorry. So I'm just using the leads, splaying them to hold the component in a suitable position. So nice and tight against the board. Okay. Don't like that joint much. Much more better. Okay. So that's it, snip the legs. So now we reassemble and see what we got. See if we're rocking out. Okay, I'm reassembling the amp now, and I haven't shown you much of it because it's largely fairly boring, I suppose, because as they used to say in the old Haynes car repair manuals, reassembly is reversal of removal. But I just thought I'd show you this bit. So getting these connectors on, getting these wires on, if they show you any resistance, you need to wiggle them. Like this one doesn't want to go down. Wiggle them side to side. There we go, that's fully home now. The reason I say that is wiggle them side to side. They've got 3 prongs that are soldered to the board. They're quite strong side to side, but wiggle them back and forth. Wiggle them back and forth. Obviously there's not so much to hold them. They're liable to actually break off if you wiggle back and forth. So when you're pushing the connectors on, if they need wiggle as you push them, go side to side. I haven't needed to consult with my photographs because I numbered all the wires on a previous occasion. But as I say, the more techno modern solution to this conundrum is to make some photographs. I'll just show you this in case it's something you don't know about. So the valves, these particular valves, I think this base is called B9A or something, they have a ring of pins. There are 9 pins, although there's space for 10. There's actually 1 missing. Can you see that? Right there? Ring of pins and a gap. That lines up with the ring of pins and a blank in a socket. Hopefully you can see that on the camera. I'll zoom in some more. Lean you over. See that? Ring of pins on a blank. Just lines up. And enables you to insert your valve. Okay, well, that confirms it. I'm going to go all the way through that amp and I'm going to replace every single cap in it. Cool. Well, thanks for joining me. That was really interesting and cool. There'll be a lot more soldering coming up anyway, that's for sure. Right, cheers, bye. Oh yeah, don't forget to like, subscribe, and argue with me about things and all that good stuff. See you in the next one.